We got involved in tidal energy development in Puget Sound when the Electric Power Research Institute was putting together a feasibility study to say, will tidal energy work anywhere in North America? And the university got involved during that study, actually looking at Tacoma Narrows, where the sound funnels down to a narrow channel, or an Admiralty Inlet, where the channel narrows, the water speeds up, and that's where you think about trying to generate power, because you have these very swiftly moving currents in those locations. We were going out characterizing a tidal energy site, and we were really battery constrained as we were doing these surveys. And so the thought was, well, wouldn't it be great if we could integrate some sort of small tidal turbine with our instrumentation package and generate our power that way? During the winter quarter, a group of undergraduates approached us and said, we'd like to get involved in tidal energy. Do you have a project we can get involved with? We said, well, we were working on this micro tidal project, and we've just been doing a lot of numerical modeling to date. We haven't actually tried to go and think about constructing anything. And they said, well, it'd be really interesting to actually go and design and construct the rotor for this.
We all felt it was feasible, and they were very energetic, very enthusiastic, and they wanted to tackle this challenge. So they put together a team of undergraduates, and then they located the right expertise in the faculty for advising.
It's been estimated there's about around a gigawatt of potential tidal energy available, which would power a substantial portion of the city of Seattle.
We've been going out every 3 months and deploying our C-Spider instrumentation platforms that allow us to characterize the physical and biological environment at tidal energy sites.
The current cost to replace the battery pack is about $25,000 every 3 months. That's when you factor in the cost of the batteries and the crew time and the ship time to get out and reel up the C-Spider and then put it back down.
After doing multiple tests, it took us probably into the 5th week before we decided on an actual design.
We've developed a testing setup which will be used by a master's student in his continuing research on this type of turbine and its potential use in Puget Sound. We found very quickly in this course that there's a lot of stuff that we don't know enough about. Here we are, we're doing fiberglass layup and had to learn how to do that and composite. So I would say a capstone course is really, to me, an opportunity to really broaden a lot of what you've learned and apply it.
It allowed us to find a problem, identify the problem, identify a plethora of solutions, and pick from those solutions the best fit.
The students in this project have done a really outstanding job. The progress they've done is phenomenal. And the result is something that we will be working with for years to come in understanding the process of generation of electricity.
The students just were amazing in the sort of skills that they brought to bear on the project.
And this is all thanks to this award. Obviously, it boosted the students' enthusiasm in the project. The fact that they were actually going to get to build what they designed really made it tangible for them.
The Capstone funding allowed them to actually fabricate the scale turbines, test them in a flume, and then have the molds fabricated for this the composite manufacturing of this full-scale prototype. And that sort of kind of hands-on, learn-by-doing experience they wouldn't have had with the Capstone. I mean, the Capstone funding definitely allowed them to do exactly that.
And I remember hearing that we had gotten the award. It was this huge relief. It was like, well, now we can plan to go and do some work as opposed to trying to just come up with a design, which is probably where we would have stopped. It really gave us the opportunity to get our hands dirty.
The generosity of the alumni and the funding that was gifted to us really allowed us to go forward with building the full-scale turbine, and it really allowed us to be picky about the quality of material that we were able to build the turbine with.
Rather than just the easiest to come by and the most economical.
So in the future, I think we'd like to try to continue the Capstone into other years and develop other aspects of the turbine technology, and then ultimately get into the product testing phase, where we'd actually be putting this out with instrumentation and verifying that it works in the sound.
If I could speak to the individual or individuals who donated this money, it's just a huge thanks for the generosity and the consideration of students here. I think that we all have greatly appreciated the freedom that it's given us to do this research, and has really allowed us to produce a high-quality project.
We're hoping that this project will be a great help for the future of the Puget Sound area and the energy programs around it.